Statics. What is it, and why should I care? Statics is one of the fundamental subjects in engineering, serving as a building block for many other subjects like dynamics and mechanics of materials. It is the study of rigid bodies at equilibrium. In other words, it is the analysis of how forces interact with the system and how to ensure that that system remains at equilibrium. Now, earlier I mentioned rigid bodies, and you might be wondering what those are. A rigid body is an object that does not deform due to applied forces. Essentially, that means that in this course you do not need to worry about the material properties of an object. Statics is centered around Newton's three laws of motion. His first law states, an object at rest will stay at rest, and an object in motion will remain in motion unless acted upon by an external force. His second law says, acceleration is a function of an object's mass and the force applied to it. In other words, force is equal to mass times acceleration. Finally, his third law states, for every action, there is an equal and opposite reaction. With these three laws, we will be able to solve for equilibrium of a given system. The main tool we will use in this course to find equilibrium is a free body diagram, which displays the direction and magnitude of all the forces acting on a rigid body. Free body diagrams are one of the most useful tools an engineer has in their arsenal. Let's cover the most simple case. A block of mass m is laying on the ground. The first thing that needs to be done is to define our coordinate system, which will be used to determine the direction of the forces. While we're at it, we should also define the direction of gravity. From Newton's second law of motion, we learned that force is just mass times acceleration. While our block is not moving, it still experiences acceleration due to gravity, which will give us our gravitational force. Now, we may think we're done here. However, from Newton's third law of motion, we know that for every action there's an equal and opposite reaction, meaning that since the block is exerting a force on the ground will also exert a force on the block. This is called the normal force. And there we have it, our very first free body diagram. In the next episode, we will learn about the equilibrium equation.